Everyone, let us see the static Kramer's drive. In this static Kramer drive, the slip power in the rotor circuit of an induction motor can be returned to the supply by replacing the chopper and resistance. So this is black diagram of static Kramer drive. It contains two different kind of bridges. One is rectifier bridge, another one is inverter bridge. Both bridges are connected anti-parallelly across the static Kramer drive of black diagram. This is three-phase fill converter static Kramer drive. The combination of the diode rectifier and phase controlled inverter is called a converter or subsynchronous cascade. The rectifier rectifies the slip frequency voltage of the rotor. When the output of this rectifier is connected to the phase controlled thyristor bridge, which operates as an inverter, the slip power is returned back to the supply through the transformer. The transformer connected on across of three-phase transmission line. Rectifier is connected to inverter through a smoothing inductor L. The phase control of the inverter brings in speed control. For the inverter, the firing angle alpha will be large, so that substantial power is fed back to the AC power bus. A large value of alpha will result in a poor operating power factor. The slip power is returned to the mains. The machine has fairly good efficiency, so the machine always operates with a nearly constant air gap flux as decided by the fixed stator voltage and frequency. The losses in the circuit causes slight reduction in efficiency, so the efficiency is further affected by additional losses due to the non-sinusoidal nature of the rotor current. Therefore, the drive motor must be slightly over-dimensioned. The motor used must have a rating 20% higher than the required power, so the constant power control is obtained by static Kramer drive. This is conventional scherbius system. Scherbius system have two static scherbius drive and conventional scherbius drive. In a scherbius drive, having converter system in the Kramer drive is replaced by a phase control cyclo converter, so that slip power can be controlled to flow in either direction. It has bidirectional power flow capability. The drive cannot only be controlled for motoring and regeneration, but for subsynchronous as well as supersynchronous speed region as well as. It is very expensive and has control complexity, but it has some advantages or a near sinusoidal rotor current that gives reduced harmonic loss and a machine over excitation capability that permits leading power factor operation on the stator side. In fact, cyclo converters input lagging power factor can be cancelled by machine leading power factor, so that this line power factor can be unity or leading. In addition, a true synchronous speed operation of the drive is possible when the cyclo converter operates as a rectifier to generate DC excitation current for the machine. During the drive operation, the cyclo converter output frequency and phase should closely track those of the rotor output. Then the step down transformer at the input reduces the input voltage of that. A cyclo converter can operate at the best DPF for the speed range of operation. Unfortunately, like a Kramer drive, The drive also requires separate resistive starting. Thank you.